This is the post-lab video for experiment number 22, mole ratios. There are 9 post-lab questions that we're going to work through together, and for each one of these I'm going to ask that you write a heading or a description for each question before you show your calculation or your work. So let's take a look at question number 1. This is at the end of experiment number 22 in your lab manual, where it says, number 1, write the balanced chemical equation for the following description of the reaction you performed in this lab. Copper wire reacted with a solution of silver nitrate in a single replacement reaction to produce silver metal and aqueous copper 2 nitrate. So let's start by writing question number 1. What it's asking us to do is to write a balanced equation. So this is what I mean when I say to write a descriptive heading. So the balanced equation started with copper wire, so Cu solid, plus, and I'm going to leave a blank in front of that because we're going to have to balance the equation, so plus silver nitrate, aqueous silver nitrate, which is AgNO3, turns into aqueous copper nitrate and silver metal. Now if you take a moment to balance this equation, it appears that coppers are balanced at 1 apiece on each side. Silvers appear to be balanced, but the NO3, the nitrate group on the left side of the arrow, there's only one of those nitrate NO3 groups, and there are 2 nitrate groups on the right side. So to balance that, I'm going to put a 2 in front of the silver nitrate. That's going to give me 2 silvers on the left, so I can fix that by putting 2 silvers on, 2 silvers on the right. So our coefficients are 1, 2, 1, 2. So that's it for post-lab question number 1. Post-lab question number 2 says, what is the mole ratio of copper to silver as predicted by the balanced chemical equation? So our descriptive heading here is the mole ratio of copper to silver. And from the balanced equation, we see that there's 1 mole of copper, and that's just referring to this part right here. And using up 1 mole of copper should produce 2 moles of silver. That's what we would expect to see in this reaction. We're going to now spend the next couple of post-lab questions determining if that is indeed what we got in our experiment. So to find moles of copper, we have to first find grams of copper. To find moles of silver, we have to first find grams of silver. So we have all that in our data table. So question number 3 says, using the data from your data table, calculate the mass of the copper wire that reacted in your experiment. So the heading here is the mass of the copper wire that reacted. And this is going to come from your data table, and everybody's numbers are going to be different. But you should have 2 masses of copper, one from the very first day, and then a second massing of copper, which was done on day 2. That second mass of copper should be a little bit less than the first one. So it's a subtraction to figure out the mass of the wire that reacted. So you'll have 2 numbers that come from your data table. This first one right here was the original mass of the data. So this was the copper on day 1, and this was the copper on day 2. So subtracting those, you should get a mass of copper, and make sure that this is rounded to 2 sig figs. All right, problem number 4. You're now going to find the moles of copper that reacted. To find moles of copper that reacted, you have to first start with grams of copper that reacted. This number comes from the answer that you just got in number 3. So you should have a number here starting with two significant figures. To convert grams of copper to moles of copper, we need a conversion fraction. Grams of copper should go in the denominator, and moles of copper should go in the numerator. This is a molar mass conversion. 1 mole of copper from the periodic table is 63.5 grams. Grams of copper will cancel, and your math, your calculator work, is your answer from number 3 divided by 63.5. Your final answer of moles of silver should be rounded again to two significant figures. My guess is here that you'll have a number, it's quite small, it should be in the neighborhood of 0.0045. In that neighborhood, your numbers will be not exactly that number, but you are looking to have two significant figures, so you have to go out 0.0045. Remember, leading zeros are not significant. So hopefully you're in that range. If you're not, then you should double check your work. Or maybe you had some error in your lab that explains why your numbers are very different. Okay, number 5. Now we are going to find the mass of the silver produced. This comes from your data table. You'll have to do some subtraction because you would have weighed the silver that was dried, that was produced and then dried. So this was the silver in the beaker that you would have measured on day 3. Okay, so you'll have a grams that was measured. This should be the silver with the beaker, but then you have to subtract out the mass of the beaker. So this is the silver plus the beaker. And again, these numbers come from your data table, and everybody's numbers will be a little different. Okay, so here you should have grams of silver, and my guess is that you should have about a gram of silver in your calculations here. You should have at least two significant figures in your grams of silver number. All right, number 6, we're going to find the moles of silver produced. To do this, you're going to start with your grams of silver. That's your answer from number 5. This is a molar mass conversion. So grams of silver goes in the denominator. Moles of silver goes in the numerator. 1 mole of silver from the periodic table is 107.9 grams. So your calculator work should be the number you had in the answer you had in number 5, which should be to 2 sig figs. You're going to divide that by 107.9, and you'll get some number of moles of silver. Again, you want to express this answer to two significant figures. You should be on the neighborhood of 0.0085 or 0.0090. Somewhere in there is the number that hopefully you are in that ballpark. I'm going to erase that because that is probably not your number exactly. Okay, number 7. What we are now going to find is the experimental mole ratio, not ration, ratio of copper to silver. So here, you're going to have to take your calculator, your calculated answers, your moles of copper, which would have been your answer from number 4. So write that in. Whatever number you had should be two significant figures. And you're going to put a ratio symbol, which is of course just a colon. And then you're going to put over here your moles of silver that you produced. This is your answer from number 6. Okay. Now this is not a whole number ratio, so we're going to make it a whole number ratio. And I am going to go on the assumption that your answer from number 4, your moles of copper, should be smaller than your moles of silver. So if essentially we're going to try to divide by the smaller of these two numbers, and it should be that your moles of copper should be the smaller of the two, hopefully, of your two mole values. So you'll divide your moles of copper by that same number. So that's going to work, you know, it's going to end up being 1 mole of copper. But you're going to take your answer from number 6 and you're going to divide it by your answer from number 4. And so this should be a number greater than 1 moles of silver. And if you remember back in question number 2, the predicted mole ratio is 1 to 2 of copper to silver. So you're hoping that this number here is close to 2. And it says here, if it is, whatever this number is here, round it to the nearest whole number, and that's how you'll express your ratio here. Question number 8 is not really any calculator work. This is just the market value of silver. And we looked it up today, and from the web today, or the last recorded value that I had access to was from 222. The value of the silver was $28.49 per something called a troy ounce. But unfortunately, we did not measure our silver in troy ounces. We measured it in grams. So we're going to have to think about that in this next question. But that's all there is to number 8. You're just recording that value from the internet. Number 9, we are going to figure out the value of the silver that you produced. And to do this, you have to start with the mass of the silver that you produced. The mass of the silver that you produced came from your answer in number 5. And this is in grams of silver, so we're going to have to do a little calculation to convert grams to troy ounces. So grams to troy ounces, it's given to us in the post lab. 1 troy ounce is 31.1 grams. That's just a given. So here we're going to see that grams will cancel. But now this leaves us, all we've done so far is converted our grams to troy ounces. But one more fraction will help us figure out the value of the silver that we produced. So troy ounces will go in the denominator, because $28.49 per 1 troy ounce is the market value. So troy ounces will cancel. And so if you see here, you take your answer from number 5, whatever that was, your grams of silver, should be a little, probably less than 1 gram of silver. You're going to take that mass of silver, divide by 31.1, you'll hit the equal sign, and then you'll take that answer and multiply by 28.49. So you'll get a final answer, the value of your silver. My guess is that it's worth somewhere near $1. All right, following up. The only thing you need to do now is I'm not going to have you write a summary. I'm not going to have you write a conclusion, but I am going to have you write improvements. All right, and so what might have gone wrong, and you're going to talk about 2 things here. What things might have gone wrong at the lab bench that would have affected your results? Like, why didn't you get the 1 to 2 ratio? And here's some obvious things that may have happened. You might have had an obvious spill or something very noticeable that might have happened, but certainly almost everybody would have lost some silver in the decanting process and would have ended up in the waste beaker. So one improvement would be to find a way to collect all the silver and not let some of the silver go over in the decanting process. Another possible improvement is to actually recover all the silver from the copper wire. It may or may not be that some silver was still left clinging to the copper wire. So that's another possibility that may have gone wrong that you could improve on if you were to do this experiment again. If there's anything else that's obvious and noticeable that happened in your experiment that you know something that obviously went wrong, please include that. Otherwise, that's the end of the mole ratios post-lab report, and you can go ahead and get that turned in. See you in the classroom.